Hello there, 8th graders. This is Mrs. Minowitz, and I'm here today to talk to you about planets in our solar system. The first thing that we need to know about planets is that in order for them to stay in motion and to continue revolving around the sun, they need two things. And the first one of those things is gravity. Now, gravity is a force of attraction between two objects. It pulls things towards each other. The other thing that planets need to stay in motion is inertia. And this is not a force, instead it is a property of an object. And it is the tendency of an object to stay in motion unless acted on by an outside force. So it's pretty much just a way of saying things are going to continue to stay the same unless there's something there that's going to change it. Gravity is actually something that we can calculate the force between two objects. And there's an equation that we're going to be using that we will use to calculate the force of gravity between different things. Now, if you take a look at this formula, or this equation here, you've got F of g, which is the force of attraction between the two objects. That's what you're going to be calculating. The capital G there stands for the universal gravitational constant. So this will always stay the same. It's a constant. You'll start to see more constants as you move up into higher level math. But basically, it is a letter that is used to represent a number. This is in units, and one of the units that you use with it is with a Newton, and a Newton is a way of measuring force. Okay. So G stands for that gravitational constant. M1 and M2 are the masses of the two objects that you're calculating the gravitational force between. And then R, which is also often shown as D squared, R squared or D squared, it can be the radius of, if you're talking about like a planet, which is essentially the distance between the two objects. So sometimes it's shown as R, or sometimes it's shown as D, but it will always be the distance that we are talking about. So I'm going to show you an example of this. We will also work on this in class, but this is how you would use this formula to answer a question. So you'll want to make sure you fill this out on your sheet so you have this as a guide for what we're going to be doing in class. So determine the force of gravitational attraction between the Earth and a boy who is standing at sea level a distance of 6.38 times 10 to the 6 meters from Earth's center. One thing about all of these equations and calculations is I will not ask you to convert units for these because there's so many different units you're using, but you should know that your final answer is in newtons. So below this problem, I've written out what it has told you. G is the gravitational constant. It always stays the same, 6.6726 times 10 to the negative 11th. I'll always give that to you. M1 is the first mass. The first mass they gave you is 5.98 times 10 to the 24th. The second M2 is the second mass, 70. Doesn't really matter which one's which. And then R is the distance they gave you, which is 6.38 times 10 to the 6th. Okay. Now, the first step you're going to do, okay, is you're going to get up your equation, and then you're going to go through and put in all of those different things. So I've just plopped in, instead of G, I put in 6.6726 times 10 to the negative 11th. Instead of M1, I've put in the number, and so on and so forth. So the first step is just to like plug your numbers into the equation. That is here. Now the second thing you're going to do is you're going to, in order to make the exponents much easier to deal with, is you're going to be combining some like terms and putting some things together here. So what you're going to do, okay, is you're going to take, okay, and you're going to put, okay, 6.6726, okay, it's just a regular number, there's no exponent there, 5.98, okay, and 70. You're going to put those all together at the beginning. Then you're going to put and combine your exponents together. And now you should know that when you multiply exponents, you actually add the exponent numbers to each other, but in this case we have a negative, so you'd subtract. So this part here, okay, is actually going to be 10 to the 13th power. Okay. Now, the bottom you can also simplify as well. You can go ahead and square, okay, the 6.38. You can square this number here. And you can also square your exponent, and you should know that when you are taking a power to a power, an exponent to another power, you actually multiply them. So when you do that, you should get 40.7, which is 6.38 squared, and then 10 to the 6th becomes 10 to the 12th. 10 to the 6th to the squared would be 10 to the 12th. Now when you go through and do this, okay, and calculate this out, okay, one of the first things that I tell students to do, okay, is simplify your numbers on the top and the bottom. So when I do that and I've multiplied these three numbers here together, I get this number here. Okay. Then the second step is to deal with the exponents. And when you're dividing, you're going to subtract. So you're going to end up taking 13 minus 12, you get 1. So this is just times 10. So when you go through and look at that, you're going to divide the front. You get 68.63 times 10. And your answer here, if you've done this correctly, is 686.3 newtons. Okay. Now, there are many ways you can do this with different exponents when you decide to combine them. But when you do this, you will want to show your work with this. And we'll go through this more in class, more practice problems. All right. So other things we need to know about gravity is more big picture. So if we had decreased the distance between two objects and we made them closer together, what would happen to gravity? Well, it's actually going to increase or get larger. If two things are closer, they have a larger gravitational force between them. The second question, what would happen to the force of gravity if you decrease the mass? If things are less massive, the gravitational force would decrease between them. There would be less of a force there. One of the other things we need to know is if we didn't have gravity, what would happen? So if we didn't have gravity, the only force that would be acting would be inertia. And that just means that it's going to keep following the same path. So if we didn't have gravity pulling on the Earth here in this diagram, what's going to happen is that Earth is going to follow path D, that arrow shown there. Because it's only going to have inertia keeping it moving in that direction, there'd be nothing pulling it towards the sun. There wouldn't be that gravitational force there. Just inertia. There are a total of 8 planets in our solar system, and we're divided into 2 groups, and we're going to talk about them by the groups that they're in. The first one is the inner planets. They're terrestrial. Okay? That means that they have a solid surface here. They are small, they are dense, and they have a rocky surface, or they're made of rock mostly. And they are more dense. Because they're made of rock, and they also take up a lot less space. So when you have more mass in a smaller space, that means that something is more dense. There are 4 inner planets, or 4 terrestrial planets. They're in order here. Mercury, it is the smallest. It is also closest to the sun. And then after that, we have, so this is Mercury. This is what it looks like. Then next is Venus. And Venus is really well known for having this really crazy atmosphere that makes it very, very hot there. Earth, and then Mars. One thing you need to know is what's called an astronomical unit. Okay. Astronomical units are based on the average distance between the Earth and the Sun, which is about 150 million kilometers. And this is a unit that is used in when we're talking about distances within the solar system. Kilometers, it just gets really hard to use because they're too small. But we don't use things like light years because a light year is actually too large of a unit to use when we're talking about something like our solar system that we would use when we're talking about things like galaxies. Here's a picture showing the different inner planets here. Pluto's not there, but it was added onto this diagram. Between our inner and outer planets, we have the asteroid belt. And the asteroid belt, if it shows here, we have the asteroid belt, and before we get to our outer planets, which start with Jupiter. The outer planets are also called gas giants. Sometimes they're also called the Jovian planets. These planets are larger than the terrestrial planets, and they are made mostly of gas. They do have a center of liquid heavy metals, so they're not 100% gas, but they're mostly gas. Our outer planets, okay, there are 4 of them, and these are in order. There's Jupiter, which is the largest. Okay. And then we have Saturn with all those lovely rings. Then Uranus, and then finally Neptune. This one is the furthest away from the sun. And if you compare them to their sizes, clearly these outer planets here are much, much larger than our inner planets as shown down here. However, when we start to put this into scale size, if we then add the sun is way, way, way larger than our planets. Much, much larger. Now, you'll see that Pluto has been crossed off on some of those pictures or showing with things with planets. That's because Pluto is not a planet, and this was shown a little bit in the presentations, but I want to be clear on it. In order for something to be a planet, it has to meet 3 different requirements. A planet has to be round. It has to orbit the sun and not another planet. If it orbited a planet, then it'd be a moon. And planets must dominate their own orbit, which means they must be the only object in it. And this is where Pluto runs into trouble. Pluto is round. It orbits the sun and not another planet, but it doesn't dominate its own orbit. Okay? If you look here, this is Pluto's orbit, and it's actually out here in what's called the Kuiper Belt, and it is not the only thing in its orbit, so that is why Pluto is no longer considered to be a planet. All right, we'll talk more about planets and gravity in class.